Hi, mathletes. Are you ready to stretch your brain? Today's question of the week comes from the workbook Problem Solving Experience in Mathematics. So here we're going to place the numbers 1 through 9 in the square below so that none of the rows, columns, or diagonals have the same sum. So let's see what we need to know. First of all, what numbers can you use? And we're using numbers 1 through 9, which means we're not using a 0. And can you use the numbers more than once? Well, since there's only 9, we cannot use them more than once. And must you use all the numbers? Yes, we have to use them all. And lastly, can any of the sums be the same? And no, they have to all be different sums. Just a reminder that sum means that you're adding it, so it's the solution to the addition problems. Okay, so you can pause the video here and give it a go. And when you're ready, just resume and see what I got. Okay, how did you do? Well, let's see. Here's what I came up with. I put in numbers 7, 2, 3, 4, 6, 5, 1, 8, and 9. And I just randomly put in numbers and then I just guessed. And let's see how we do with the sums. So the first row, the sum is 12. The second row is 15 and the third row is 18. So far that looks great. Now let's do the columns. So the first column is, oh no, I have 12 for both. That's not going to work. Let's just see what the other ones come up with. The next column is 16 and the last column is 17. For the diagonals, the sum of 1, 6, and 3 is 10. And the second diagonal, 7, 6, and 9 is 22. So it looks like the first row and the first column are the problem. So let's do a little strategic planning here. I think what I'm going to do is I'm going to rotate or swap out the 7 and the 2. So I replaced the 7 with the 2 and the 2 with the 7. Now I'm going to do the same thing, but this time with the 5 and the 9. And so I just replaced it. So the 9 became a 5 and a 5 became the 9. So I used all 9 numbers. Now let's figure out the sums. Now the first sum's not going to change for the first row because again, it's 2, 7, and 3, and order doesn't matter. Okay, for the second row is 19. That changed, and the last row also changed to 14. But now I know that the first column is going to change, and that's what I really did want to change because we can't have two 12s. So now it's only 7, which is great. The second column is 21, and the third column is 17. So far everything looks great. For the diagonals, I have 10, and I have 13. So yay, that one worked. But you might have said, I got something different. That's very possible because there is more than one solution to this puzzle. So here are a couple of other solutions. You can pause the video here and see if yours matches with either one of those. All right, would you like to do an extension? Here we go. This time we're going to do a 4x4 grid and we're going to use the numbers 1 to 16. And we're going to use the same rules that we did before. You have to use all the numbers. You can only use them once. And the sum of the rows, columns, or diagonals cannot be the same. Okay, again, you can pause the video here, give it a go, and when you're done, you can resume. Okay, welcome back. Was this one easier or harder to do? Here's what I came up with. All right, and so when I did my rows, I got 49, 19, 29, and 39. That checks out. For the columns, I got 22, 26, 30, and 58. Again, none of them are repeated. And for the diagonals, 31 and 33. So yay, it worked out. I hope you had fun with this one. And remember, if it felt tricky, that just means that your brain grew. If you haven't subscribed yet, make sure that you do subscribe so that you can get these puzzles or questions every week. And if you like the video, click the like button. And if you leave a comment, I would love that too. Thanks again for watching.